Remember the three intermolecular forces: hydrogen bonding, dipole-dipole, and London dispersion forces. Hydrogen bonding is very strong. Dipole-dipole, strong, but not as strong as hydrogen bonding, and we have the weakest London dispersion forces. Now, how does this relate to melting or freezing point? Melting point is a point in which where solid changes into liquid. So solid to liquid. Freezing point is a point in which the liquid forms into a solid. Whether it's solid to liquid or liquid to solid, they both will happen at the same temperature. Now, for hydrogen bonding, a molecule with hydrogen bonding will experience high melting or high freezing point. What that means is it requires more temperature in order for the molecules go from a solid to liquid. For dipole-dipole, intermediate or in between, um, the uh, the next one, which is the low melting point and freezing point. So something with the London dispersion forces requires an extremely low temperature in order for it to melt. But for something with dipole-dipole, it requires a little more heat, whereas something with hydrogen bonding, it's going to require a lot more heat in order for something to melt. To further explain this melting point, let me illustrate with an image. So here I have three different solid cubes. Here is an ice cube on this one. This is HCl cube, and then we have chlorine cube. Now this will melt by adding of heat. So heat has been added and it's going to break off the hydrogen bonding that is in between the two molecules. So it's going to break off after it has melted. So it's breaking off, and as it breaks off, some of the hydrogen bonding breaks, some of them are a little loose. They're kind of further away from each other. So therefore, it has the ability to go from solid to liquid. And that happens not only in something with hydrogen bonding, but it's going to happen with something that with dipole-dipole and also for London dispersion forces. The thing is, it requires a much more heat in order for this hydrogen bond to break because a hydrogen bond is fairly strong. So something that is strong, it's going to require more heat, more heat in order for that to break apart. And similarly, this one, it will require heat in order to break apart, but because they're not as strong as hydrogen bonding, it doesn't break off as it doesn't need that much energy in order for it to break off. And lastly, something with only London dispersion forces, well, it does still require heat, but very, very little in order for it to break off or to become more loosened up so that the solid becomes a liquid. And that's how something is melted. And this also, this is how the melting point is applied in hydrogen bonding, dipole-dipole, and London dispersion forces. Let's do a learning check. Which of the following has the higher melting point, benzene or phenol? Now, I want to give a little hint here. A molecule with just hydrocarbon, meaning just hydrogen and only carbon, will form into a nonpolar substance. Even though one has more polarity or more electronegativity than the other, but if it just has hydrogen and just carbon, we consider that as a nonpolar substance. Hopefully that gives enough hint to solve this problem. So coming back from the pause, benzene is a hydrocarbon, meaning it is a nonpolar substance. All nonpolar substances will participate only in London dispersion forces, LDF. Phenol also is a hydrocarbon, but it has oxygen present, so it's not fully hydrocarbon. So phenol has the ability to do hydrogen bonding since we have that oxygen and that hydrogen that is directly attached to the oxygen. So this will participate in hydrogen bonding. But not only that, it will also participate in LDF since all molecules can participate in London dispersion forces. Therefore, phenol is the one with the higher melting point.